Hey everyone, this is James from the Dev Genie Academy, and in this episode we're going to be rendering a texture to the quad that we created to the screen last week. So without further ado, let's get on. First of all, what you're going to need to do is create a new class called texture. This will be in the entities package. This is a very straightforward class. All we're going to have is an integer for an ID and a constructor that grabs the ID and then a getter for the ID. That's literally it. All we'll need to do now is into the model class is create an instance of that texture. Instead of adding it to the constructor that we already have, let's go ahead and create a new one instead of overwriting the existing. So it's the same constructor with the addition of texture, and we also need a constructor just with a texture, but we'll also need another model as an instance as well. So this ID will equal model.getID, and this vertex count will equal model.getVertexCount. So we could have one model that's untextured, but the same model again with a texture on it. So all we need to do now is a get and a setter for the texture. And into the object loader now, we need to create a new float array in the load models function. It's going to be texture coordinates, and we can copy the store data in attribute list function. It's going to be attribute number 1, and the vertex counts are going to be 2. And instead of vertices, we add the texture coordinates there. And instead of having this vertex count here, we should have changed this last week, we just do indices.length. So next up in the object loader class, we need to create a new function called an load texture. It's going to output an integer, and it takes in a string file name. Of course, we need to throw an exception so we can tell the user if there is any issues loading this particular texture. We need an integer for a width and height. We need a byte buffer as well. And wrapped in a try, we need to do a memory stack, and this needs to equal a memory stack.stack push. So inside of the try, we need to then say an int buffer of w equals stack.mallocint, which is a size of 1. We need to do this 2 more times for the height and the number of channels. So it's all going to be one integer in size. Next up, we need to create the buffer. So this is going to be buffer equals stbimage.stbi load. This takes in the file name, the width, the height, the channels, and the number of channels, which is 4. If the buffer is null at this point, we can then tell the user that the file was unable to be loaded. So we can do a throw no exception, image file, pass in the file name, and not loaded. So that should inform the user of what the issue is, and we can also add in a stb image failure reason as well. If we don't get the error, we then say the width equals w.get, height equals h.get. Outside of the try, we can now say our integer of ID is equal to GL11 GL textures. Before we can go any further, we need to again also create a list, like we did with the VBOs and the VAOs. Name this list textures, and after the ID, we can then say textures.add ID. So after that, we then just do GL11.GL bind texture, and that takes in a parameter of GL11 texture 2D and the ID itself. After that, we can do GL11 pixel store I, make sure the I is there, and that's GL11 unpack alignment with a parameter of 1. Next up is GL11 text image 2D, and again it's GL11 texture 2D, 0, GL11 RGBA, the width, the height, 0 again, and RGBA again, and GL11 unsigned bytes, and finally buffer. After that, we then do GL30.GL generate bitmap, which again casts in the GL texture 2D, and we can then do the STB image.STB image free, pass in the buffer, and then finally we just return the ID. So now we've got an instance of that texture being created. And finally, in the cleanup method, we also need to do another for loop for the textures that we create. And we can just call them textures. We can then do textures again, but we need to do GL11 delete textures. So that will tidy up all of our code when we go to clean up. Okay, in the shader manager now, we need to have a private final instance of a map, which is going to be a string and an integer. And this is going to be called uniforms. So these are the variables that we pass across into GLSL. First of all, we need to instantiate that in the constructor. Now we need a way to pass information across into that map array. So we can create a public void create uniform. It's going to pass in a string of uniform name. We also need a throw an exception as well in case we do have any issues. We need an integer for the uniform location, and that's going to be gl20.gl get uniform location with the program ID and the uniform name. If that uniform location is less than 0, then we can throw a new exception and tell the user that there is an issue, so it could not find uniform, and then pass in the uniform name. If we can carry on, we then pass that uniform name into the uniforms along with the uniform location. So now we've got that stored in the uniform, we can now set some uniforms. So public void set uniform with a string of uniform and matrix 4f of value. Let's create a try first. So inside of the try, make a memory stack of stack. That needs to equal memory stack.stack push. Inside of the try itself, we can then do gl20.gl uniform matrix 4fv. Make sure it's 4fv, and we pass in the uniform name. We do uniforms.get uniform name. Oh, I need to change that to uniform name as well. And we pass in false and the value.get stack.malloc float of 16 because the 16 floats in a matrix 4f. So next up we can create a public void set uniform again with a string of uniform name again. Instead of a matrix 4f we do an integer. This one's fairly straightforward. It's gl20 gl uniform 1i, and we pass in the uniform name, uniforms.get uniform name and the value itself. I think that'll be enough set uniforms for now. So in the render manager, after the shader has been linked, so after shader.link, create shader.create uniform, and this is going to be a texture sampler. And now in the render method, after we do shader.bind, we can then do shader.set uniform. We pass in the texture sampler, make sure that these strings are exactly the same and they do match, and we pass in the value of 0 there. So after we've enabled the vertex attribute array of 0, we need to activate vertex attribute array 1, and after that we can then do gl13.gl activate texture with gl13.gl texture 0. It needs to match the value we've set in the uniform. So now in GL11 we can bind the texture of GL11 of GL texture 2D, passing the model.getTexture.getID. We now need to make a change to the next line, so instead of draw arrays, we need to do draw elements. This then means we need to make some changes to the attributes. GL triangles is fine, type needs to change to model.getVertexCount, or I could have just got rid of it altogether, but never mind, let's delete that. And then do GL11.gl unsigned integer, or int, and indices at 0. We also need to disable the vertex attribute array of index 1. That's everything we need to do in the render manager. So in our test game, if we go into the init method, we can see there's an error, but we'll correct that now. Let's create a float array of texture coords, and that's going to be 8 digits. It's going to be 0, 0, 0, 1, 1, 1, and 1, 0. So now in our load models method, we do vertices, texture coordinates, and then indices. We can then say model.setTexture is going to equal to a new texture of loader.loadTexture of textures grassblock.png. So in the folder structure itself, so this is the project folder, let's create a new folder in the root, call it textures, and inside of textures, let's just drop this grassblock.png file that I have here. It's very basic, it's a quick Google search, you can find it. It needs to be exactly the power of 2. So as you can see, mine is the vertices array needs to change as well. I will leave that in the description down below. So in our vertex, we need to do positions of texture coordinates. It needs to be a vector 2. And output a frag texture coord. And that again needs to be outputted as a vector 2 as well. So in main, instead of passing color through here, we can get rid of that, we don't need it anymore. We can do frag texture coordinates equals texture coord, and again we need to make sure that's a vector 2 because I almost forgot. So that's all we need to do in the vertex. In the fragment, instead of passing in the color, we pass in again the fragment texture coordinates, and we pass out the frag color again, that can change. And we also need that uniform of the texture sampler that we had before. I'm going to call it sampler2D texture sampler, and instead of doing this vec4 of color and 1, we can now do texture, a function called texture, pass in the texture sampler and pass in the fragment texture coordinates. So when we go to run that now, we can see our quad is rendered with the grass block images, and again, see it in the description down below for the updated vertices that you need to copy down as well. Thanks very much for watching, everyone. Any questions, leave them in the comments down below, and I'll see you next week. Thank you.